Good evening, everyone. Welcome back to another Planetarium live stream. Hopefully we're coming through loud and clear. I'm fiddling with some audio settings, which we'll see how that'll factor later in the stream. My name is Patrick Hess. I'm the Planetarium Specialist here at Union Station. And thanks for joining us for yet another live stream. If you're tuning in for the first time, welcome. We're going to take a deep dive into an astronomy topic today, and tonight should be a fun one. We are going to dive into a bunch of movies. We're going to do our second Hollywood live stream. We're going to talk about the science, specifically the space science of some of our favorite blockbusters through the years. So it should be a lot of fun. If you're tuning in for the first time, don't forget, you can't forget because you don't know, but if you're tuning in for the first time, this is a live stream, so we are coming in live. That means if you have any questions or comments, be sure to put them in the comment section, and I will try to answer them. Also, just let us know where you're watching from, or just say hi. You know, it's kind of fun to have a dialogue with y'all, and it makes it feel a little more lively and interactive. And of course, if you're coming back and you are a long-time watcher, thanks for joining us yet again. Hopefully you enjoy this stream. Should be a pretty fun one. And we are probably going to just dive straight in here because I have quite a few topics to cover tonight. And so, like I said, we are going to be doing our second Hollywood live stream. So our first Hollywood live stream happened back in July of last year. Man, July 20th, that felt like 20 years ago. A lot has happened since then. But during that live stream, we covered a lot of movies. We talked about, well, first of all, we talked about whether or not the moon landings were faked. So that's a fun topic. But we also talked about Apollo 13, talked about Interstellar, Christopher Nolan's 2014 hit. Talked about Armageddon, as well as Independence Day 2 and 90s big blockbusters. And then we also touched on Hidden Figures and the truth behind that story, that great story from that film from 2017. So once again, if you want to rewatch any of our past live streams like that Hollywood live stream, then you can find all of our live streams on our YouTube channel. Just search for Arvin Gottlieb Planetarium there on YouTube, and you can find them there. We've done a bunch of other live streams on similar topics. For example, we covered fictional universes from books on May 20th. We did a whole live stream on Harry Potter and its connections to astronomy on June 3rd. And then we did a live stream all about television, so TV shows and their connections to astronomy on September 28th. So be sure to check that one out. Rewatching any of our past live streams is a great way to support the Planetarium. But don't forget that the Planetarium is also open to the public right now. So, of course, a great way to support the Planetarium is to come and watch one of our shows. If you feel comfortable joining us, we would love to have you at one of our live Star Tours or any of our other great programs. We have a ton of great options, and right now we are open Thursday through Sunday. So feel free to check us out if you feel comfortable. We are, of course, following all of the mayor's safe protocols for the pandemic. So keep all of that in mind. But of course, buying a ticket is a great way to support us, and watching our live streams is a great way to support us. So thanks for continuing to do that. Before we dive in, we're already getting a bunch of people commenting. One of our longtime watchers, Chris, is watching. Chris says, "Hello, Patrick. Good to see you again. Good to see you virtually, Chris. Thanks for watching yet again." We've got Larry Lee saying hello. Hello, Larry. Thanks for watching. Caitlin says, "Hey, first time. I'm from Wyandotte County." I think that's what WYCO means. Either that or Wyoming, Colorado. I don't know what that means, but I assume it's Wyandotte. But thanks for watching, Caitlin. Thanks for tuning in. Hopefully you enjoyed this one. Ashley says hello from Warrensburg. And then we've got Linda saying, "I love this." Well, we love that you're watching, Linda. Rachel says, "Yay, I love sci-fi." Hi from Leavenworth, another one of our longtime watchers, I believe. Mike is watching from Hawaii. Aloha, go Chiefs. Heck yeah. Hey, Google, stop. Sorry, that was I apologize if I activated any Googles. I'm going to do this very satisfying act of plunging my French press here. Ooh, yeah. It's always so satisfying. Mike, thank you so much for tuning in from Hawaii. Also, go Chiefs. I'm so glad that we've got Chief supporters from all over the world and everywhere in the States. Rachel says, "I hear Phoebe." Hello, Phoebe. Rachel says, Phoebe says hello too. You know what? I think Phoebe wants to be a part of this stream, so let's get her out here. Come on, Phoebe. Come on out. We'll see if she wants to join us. And Linda says, "Born here in KC Mo." Well, thanks for watching, Linda. I was also born in the Kansas City metro area, and I am still here today. Kathy says, hey there from Gladstone. Thanks for watching, Kathy. Austin says, first timer. Love the birds in the background. Well, we'll see if she comes out in the foreground. Austin. Tasha's watching again. Says, good evening, Patrick. Got the whole family watching. That's so awesome, Tasha. Well, say hello to everybody for me, for sure. Or I can say hello since they're watching. Thanks for watching. That's so great. Kyle says, hello from Apella, Iowa. A lot of awesome people and awesome places watching tonight. We're going to put a bookmark right there. So any more comments, I will make sure I don't miss. But we are going to go ahead and get things started because I always bite off more than I can chew with the content we're going to cover. And let's see if Phoebe wants to join us. Oh, okay, here is Phoebe, my assistant. She is a rose-breasted cockatoo, or a galah, as they call them where she's from, Australia. So you want to join us, Phoebe? Hello. She'll probably just get scratches all night. All right, so we're going to dive into television astronomy, and we're going to start with the #1 request from last time, which we did not cover. So we definitely wanted to start with that this time, and that is The Martian. This wonderful 2015 flick based on the hit book from around that time. A lot of people really love that movie. I did as well. And it was a really great movie. It was action-packed for sure. Who doesn't love rescuing Matt Damon from being stranded on a different planet? That tends to happen a lot for some reason. But also, this was a cool movie because there was a lot of good science inside of it. And we're going to kind of dive into a little bit of that. One thing I wanted to start with is just some terminology. So in that movie, they describe a lot of the happenings on Mars and part of the Mars mission in sols. So that's S-O-L. So they say on Sol 300 or something like that, referring to the number of days that they've spent on Mars. Now, the reason we don't just say day and we say sol when talking about Mars missions is because one day on Mars, that's from sunrise to sunset, is a little bit different than Earth. So one day on Earth is 24 hours long, as we know. But on Mars, a day is 24 hours and 40 minutes long. So Mars spins a little bit more slowly. And real NASA scientists who work on Mars missions, like the rover missions, actually operate on a sol schedule. So their sleep schedule is kind of based on the sunrise and sunset on Mars. So it's kind of interesting that these astronauts will have to have a special, clock to follow Mars time. Or not even the astronauts. Well, in the movie, the astronauts did. But even real scientists, what I'm trying to say, follow Mars time. And even when you hear about people talking about the Curiosity rover, and then pretty soon next month when the Perseverance rover lands on Mars, they'll be discussing its mission in sols. And that will refer to how many days that it's been on Mars. So let's talk about the very beginning of the film, and that was the sort of rising action that led to the drama and led to the astronaut being stranded there. And that was a dust storm. So here's a little clip, which I'm going to briefly cut away from just in case the copyright strike hits us. But so there was a big dust storm on Mars, and that is what eventually stranded the astronaut there, Matt Damon. And now, this dust storm looked very violent, and even in that clip, you saw it was really dark. Let's maybe we can cut back to it real quick, just for a second. So it was so dark, and that dust was really flowing and blocking their view, and they had a hard time getting to their rocket to escape. Now, the winds on Mars can get really fast. They can get anywhere from 50 to 100 miles per hour. But the difference is that the atmospheric pressure on Mars is only about 1% of the pressure of Earth's atmosphere. So even though the winds are that fast, they are not as forceful. And so an actual windstorm on Mars would not have nearly as much force as the one depicted in the movie. It wouldn't blow anything over, really. It would hardly make a flag blow in the wind, really. And we can actually see the effects of dust storms on Mars because we have rovers on Mars. And so here is a great double shot showing Curiosity, the year it landed in 2012, as well as 2019, a couple years ago. And it survived many dust storms like the astronauts in The Martian would have survived or would have experienced. But as you can see, it is still kicking, and it's just kind of dusty. So it's just covered in a little bit of dust there. There's another great interactive... How's this for multitasking? This bird is just climbing all over me. There's another great interactive that I can show you. This is on the the NASA exploration rovers, and you can actually scroll. This is... oh, hello. This is the Spirit and Opportunity rover here, and you can actually see the dust storm comparison of the solar panels. And with solar panels, you definitely don't want them to get dusty because that will block their the sunlight that they can receive. But fortunately, the Curiosity rover and the Perseverance rover, which lands next month, those are nuclear powered, so they will not be affected by dust storms nearly, or they have not been affected by dust storms nearly as much. So you can see some more interactives here showing this is a color calibration that they can actually use to help them adjust the cameras based on the dust. They can kind of account for the dust, sort of taking it out of their camera views. So kind of cool little interactive there. But let's continue on. So another thing that was depicted in the movie was artificial gravity. So in The Martian, their spaceship that they traveled to Mars from Earth and back and forth in this case is called the Hermes spacecraft. And it had artificial gravity using a spinning ring. And so they could actually walk around with a perceived Earth-like gravity. Now, this proposals for this type of artificial gravity had actually date back to the 60s. In fact, there were some NASA proposals for spinning spacecraft that could have produced this effect. And this effect was also seen in another movie, 2001: A Space Odyssey. And this movie came out in 1968, and it actually had a pretty accurate depiction of artificial gravity. So basically, by the astronauts being in this spinning torus type spacecraft, they could experience this Earth-like gravity. There are proposals for future missions. Actually, in 2011, there was an International Space Station proposal for a spacecraft called the Nautilus X, which would have produced artificial gravity aboard the International Space Station. Unfortunately, that didn't really get off the ground. There was no funding for it. But, they could use this proposal in the future. Now, how exactly this works is due to something called centrifugal force, and the physicists in the audience will definitely be triggered by this discussion because a lot of people claim that centrifugal force is not real. Now, that is true and not true. Centrifugal force is an inertial force that appears to act on an object in a rotating frame of reference. So it's a perceived force. It is still a force that exists, but it's a little bit different. And again, we're not going to dive too deep into how physics works there. But a real world example of this would be if you're in a car taking a really tight corner, turning a corner very quickly, you can feel yourself getting pushed to the edge of the car in the direction away from the direction it's turning. So you've experienced that centrifugal force, certainly. And now this force was actually experienced in the Gemini 11 mission. They tested this out on purpose. That mission the primary point of that mission was to dock with another vehicle in space called the Agena module. But as part of the mission, they attached this module. It was another module besides the Gemini module. They attached it to a 36-meter long tether and actually spun it around with the rocket engines. And they were actually able to generate a small amount of artificial gravity. The astronauts on the spacecraft didn't actually, they said they weren't able to feel it, but they actually did watch objects kind of floating to one side of the capsule or towards the floor. So we have proven that this exists, and of course we know, thanks to physics, that it does exist. Now, there's some challenges with rotating crafts like these. So even though in The Martian, this is a fairly realistic idea of how we could produce artificial gravity, one challenge is that it require a lot of force and a lot of rotation to match the feeling of being on Earth. The speed of rotation is proportional to the size or the radius of the craft. So, for example, a 200-foot radius torus, so a sort of a ring that's 400 feet wide, would have to spin once every 15 seconds to match Earth's gravity. And then if we wanted to spin it more slowly, once every 30 seconds, it would have to have an 800-foot radius. So it would have to be 1,600 feet wide. So this grows proportionally like that. And so it would take a lot of energy to get an object like that spinning, because obviously it would be very heavy too, of all the metal and other spacecraft materials. Another thing is that in the movie there was only one spinning object, or one spinning torus where they would walk on. And the problem with this is that it would create a gyroscope effect that would cause the rest of the spacecraft to spin. So this is actually pretty. This is a big problem with the movie. If they had another torus that was rotating in the opposite direction, that would actually kind of counteract that. And in fact, in the movie's 2001: A Space Odyssey, I don't think I have a picture of it, but they actually had two toruses that were rotating opposite directions. So even in 1968, they actually got that right, which is kind of cool. And then, not to mention the cost that it would take to transport something like this into space. But, it's in the future, and we'll spare no expense to get Matt Damon back here on Earth. Another thing that happened in The Martian. Ooh, nice. Oh, way to go, Phoebe. Way to poop and get that in frame. We're going to take a quick pause here. Well, if there was ever any doubt we were doing this live, hopefully that doubt is dispelled. Thank you for that, Phoebe. I think that was our first on-screen poop since we started these. So that's, I guess, pretty historic. Anyway, as I was saying, Matt Damon has to fashion some drinking water on his mission. And in the movie, his character took some hydrazine from the rocket fuel and disassociated it into nitrogen and hydrogen, which you can actually do. There's science to that. And he burned the hydrogen with oxygen, which made water. Now, that will work, but if you were stranded on Mars, there'd be a much easier way to get water. You could just take it out of the soil. So on Mars, there is actually a lot of water in soil. Now, in 2013, the Curiosity rover actually took some soil samples and it found that Martian soil is about 5% water by weight at low altitude and up to 60% water near the poles. So there's actually a lot of water on Mars, and this is why scientists today think that Mars was likely covered in oceans of water in its distant past. This is probably the way that future Martians are actually going to get their water. Another thing I wanted to talk about real quick is that in the movie, Donald Glover's character came up with an idea to use a gravity assist to rescue the mission and to get the astronaut back. Now, in real life, NASA and the Jet Propulsion Laboratory used a similar person. So you can kind of argue that Donald Glover's character was maybe modeled after a real person named Mikhail Minovich, who came up with the gravity assist idea in the 1960s, which they eventually used for the Voyager space programs. So a lot of truth to the Martian missions. We're going to pause real quick and check into the comment section, see who's saying hi. We've got a lot of comments. Right now, Phoebe is just chewing on my green screen, so I'm not going to worry too much about that. We've got Sue saying hi from Liberty. Thanks for watching, Sue. Caitlin says, Caitlin's clarifying, yes, from Wyandotte. Thanks for clarifying, Caitlin. Melinda says hi from Belton, Missouri. Thanks for watching, Melinda. Emily watching again. Hi, Patrick. Hey, Emily. Thanks for tuning in. Martha says, ooh, French press coffee is the best. Hello from Gardner. Yes, it's pretty good. I'm going decaf today. Also, my Dirt the Cat mug here. Dirt is the best cat. Just FYI. Feel free to Google that. Paula says hello from Eureka Springs. That's a great town. I love Eureka Springs. I visited there a couple years ago. Paula, thanks for watching. So great you're tuning in. Patience says hi, pretty bird. You hear that, Phoebe? Somebody likes you. Thanks for watching, Patience. Thanks for tuning in again. Marie says hello from St. Charles County, Missouri. Thanks for watching, Marie. John and Kathy, hello from Florida. Hello, guys. Amber says, this is really cool. Tammy says hi from Iowa again. Thanks for watching, Tammy, one of our longtime watchers. David says hello from Minneapolis. Eric says, Granny says hi from Lenexa. Hi, Granny. Thanks for watching. Jenny says, what a cool series. Sure miss living in KC. Well, KC misses you too, Jenny. Eric says, Eric asks, does NASA really have the tech to regenerate oxygen and water like they have on Mars seem to do? So I mentioned that a little bit. Hopefully I answered that question. And we can definitely do that with rocket fuel. That is scientifically and chemically possible, I guess. But like I said, we probably won't have to do that. Granny read years ago, the same old movies from the 50s were spot on for space travel. Is that true? Maybe we should do another live stream someday on classic space tech. I think that'd be a lot of fun. Actually, I might have a plan for that already. And Amber says, in terms of a spinning space station, once the correct rotation is achieved, it shouldn't cost any more energy to maintain, right? Friction should be minimal since the pivot point should be well greased. And you're right to a degree, Amber, definitely, once things are spinning. The problem is there will always be a little bit of friction because that spinning craft... there will just always be friction. So even with all the grease you could use, there will still be some friction. Plus, there will be friction from oxygen. So even in low Earth orbit, like in the space station, there's a little bit of oxygen, and the space station has to actually boost itself up every once in a while so it doesn't fall back onto Earth. There will be a little bit of energy needed, but perhaps in the future our technology could be good enough that solar power could produce that energy and it could be sort of self-sustaining. Donna says, watch from Eudora. Thanks for watching, Donna. And Jeannie says hello from Harrisonville. Connie, hi from Michigan. Thanks for tuning in, everybody. We're going to put another marker right there, so anybody who comments after this point will be sure to catch you, but we got to continue our stream already at 6:20. Oh man, I am always so long-winded. Thank you guys so much for being patient and dealing with my very, very verbose talking. I'm getting a little worried about my bird. Let's see if she'll join us again. She's chewing on my window blinds. Phoebe, hello. Here, let's do this. Come here, bird. All right. Let's see how long she lasts here. All right, I wanted to touch on an obscure movie that you may not have heard of, but it was actually suggested by David last week. So thanks for giving us this suggestion, David. It's a crazy movie, which is called The Wandering Earth, and it came out a couple years ago, 2019. And it's a Chinese blockbuster, actually one of the biggest blockbusters that has ever come out of China. And in this story, in The Wandering Earth, it tells the story of a distant future in which the sun is about to expand into a red giant and devour the Earth. And so mankind decides to try to save the planet by developing a multi-generational mission that will basically put rocket engines on planet Earth and fly it through space to Proxima Centauri, which is the nearest star system. And then it's a 2,500-year journey where there are heroes that emerge and all sorts of drama ensues. And so you can see this is the picture of the Earth with rocket engines attached to it. Now, it's kind of a crazy story, but there might be some scientific truth to it. And we're going to get my bird again. Give me 1 second, folks. Come here, bird. Here. All right. So, with the bird back in the cage and the poop drying on the shoulder, let's talk about The Wandering Earth. So, in this movie, first of all, the premise is that the sun is expanding into a red giant and that it will absorb the Earth. Now, there is definitely some truth to that in some way. So, we're going to load up Universe Sandbox, which we've used a couple times. It's a simulation game sort of thing where you can do all sorts of cool physics simulations. So while this is loading up, now it is true that the sun will turn into a red giant. Now we talked about stellar evolution way back, all the way on April 15th of last year, where we talked about how stars are born and how they die. And so check that stream out if you want to learn more about that. But suffice it to say that the fate of our sun in about 5 billion years is that it will expand into a red giant. Now, in the movie, this happens in a couple decades, but that is definitely not going to happen. Barring some crazy unknown thing that surprises us that happens to the sun, we have a long time before we have to worry about the sun expanding. But what would happen if the sun did expand to the Earth? Now, let's go ahead and load up a simple simulation of the solar system here. And we have the sun. Now, in our Universe Sandbox, we can actually edit properties about the solar system. So I want to pause here, and what I'm going to do is actually, I'm going to replace the sun with another star, and I'm going to replace it with a red giant of similar size. Now, let's see, which one should we choose? I'm just going to double check that we pick a star that is a similar mass. Great. So we're going to go with Arcturus, which is a similar mass star that is a red giant. It's a specific spectral class, but we won't get too deep into that. But we're going to replace the sun with a red giant of a similar mass. So this is about what the sun will be. How big it will be when it... well, that's not actually quite accurate. So Arcturus is the wrong type of star. We're going to go with Betelgeuse, which is a pretty similar choice. So there we go. That's a little more like it. So replacing the sun with a red giant of a similar size, you can see that it, well, it's bigger than the orbits of both Earth and Mars, and that would be very bad for the Earth. So when this happens, it would indeed be very bad for the Earth. And so one thing we might want to do is move the Earth. Now, in 5 billion years, humanity will probably have evolved to be unrecognizable, or we'll be living out somewhere else in the universe, hopefully. So probably the solution won't be to move the whole planet. But let's imagine for a minute that we did really want to move planet Earth. This is kind of a fun thought experiment. Now, in the movie, it took, let's see. So in the movie, it took them 17 years to move the Earth all the way over to Jupiter, and most of the action takes place when they get to Jupiter. Now, doing some math, it would take about 10 kilometers per second of delta V, which we talked about delta V in my December 14th live stream, where I talked about rockets and how they work. We actually built a rocket and flew it on stream, so check that stream out. That was a lot of fun. But we're going to save a lot of the math. But essentially, in the movie, there were 10,000 Earth engines that they called, and they strapped them all over the planet, as you can see in the picture here. And if we did the math, to provide that much force, that much thrust, basically, Each engine would need to produce about 2.5 quadrillion pounds of thrust. Now, the F1 engine on the Saturn V rocket, which is what NASA used during the 60s and 70s to get to the moon, was the most powerful single-nozzle liquid-fueled rocket engine ever developed. So that engine is the best thing we've ever made, and that puts out about 1.5 million pounds of thrust, which is a tiny, tiny fraction of the required thrust that each of those engines in this movie would have taken to actually move planet Earth. Also, in the movie, which is also based on a short story, by the way, it says that the largest engines, these Earth engines, are 6,000 feet taller than Mount Everest. So we're a bit far away from the science to be able to achieve this. Plus, the required energy to produce, to power these rockets would require us to mine out about 95% of Earth's mass, which there wouldn't be much left of Earth to actually move at that point. So that part is, as you might imagine, a little less plausible. Another thing is, if we took the Earth away from the sun, things would get a bit chilly, which they do account for in the movie. The Earth gets very cold. In fact, some characters go outside and they record the temperature in Beijing at minus 120 degrees Fahrenheit. Now, by comparison, at another place around Jupiter called Ganymede, one of its moons, the average temperature on the surface is minus 170 to minus 300. That's a bit colder, but Earth does have internal heating in its core, so that might keep things a little bit warm. Oh, there's a picture of one of those Earth engines. So I just wanted to bring up the Wandering Earth. David, hopefully you're watching, and hopefully that answers some of your questions about that film. All right. Don't forget this is live, so if you have any questions or comments or just want to say hi, be sure to put that in the comment section. Amy says, watching from Blue Springs, Missouri, and Amy says, aloha. Aloha, Amy. Thanks for watching. All right, I'm going to move on to another film that came out a couple years ago and kind of went under the radar. Not a lot of people knew about it. It's called Ad Astra. It's a really great movie with Brad Pitt. I won't go too deep into the plot because there might be some spoilers in there. But one thing I wanted to talk about that pops up in a couple movies is this concept of a space elevator. So the movie starts that Brad Pitt's character is working on the side of this space elevator. Now, a space elevator is a proposed type of planet-to-space transport system that basically would have a spaceship up in space on a tether that was orbiting at the same speed as the Earth is rotating, and then the tether would go all the way down to the ground. And the cool thing about this is, first of all, it was proposed centuries ago, in the late 1800s, actually. The first idea for a space elevator was proposed. And relative to rockets, a space elevator would be really cheap and way faster to get cargo and people off the Earth. Now, the biggest challenge would be in construction. So let me show you this graphic here. And this shows us sort of the scales involved. Because for this space elevator to work, a part of it would have to be in a geostationary orbit, which is very, very far away, about 26,000 miles away. And so this tether would have to be incredibly long and very, very strong. The required strength of this cable would be incredible. It would vary along the length, but it'd be much stronger. It would need to be much stronger than any material we know of today. There are some materials that could potentially be strong enough, like carbon nanotubes and this recently created material called diamond nanothreads. Those are the top candidates, but this is definitely still in the realm of science fiction, an elevator to space. I will say, though, that there is a nonprofit organization called the International Space Elevator Consortium, and they are very convinced that this is the best way to go into space. So they are working on developing space elevators to get to space. So who knows, might be there at some point in the future. Now, in the movie also, let's go over here to Space Engine, because this movie, Brad Pitt's character flies to a couple different planets. At one point, he goes to Mars. Now, the colony on Mars is all underground in this movie, which is pretty accurate because we talked about Mars before. In fact, I did a whole live stream on Mars on August 10th of last year. But Mars has a very weak magnetic field, which means it's not protected from solar radiation. So if you were living on Mars, you couldn't be hanging out on the surface without some kind of protection. Even just a space capsule wouldn't protect you. You'd need something to protect you from the radiation specifically. One idea to protect humans who are living on Mars in the future is to be underground. And so it's kind of accurate that those astronauts were potentially living underground. And then at the very end, the climax of the movie takes place around Neptune. And we've talked about Neptune before as well. Our Neptune and Uranus stream was on December 7th of last year. But here around Neptune, he actually flies through Neptune's rings. And Neptune does have rings, you may not have known. They're going to be really hard to see here in Space Engine. But if I angle things just right, you might see just a little sliver, a little line kind of glaring through the sun here. In fact, I can cheat and just make things way, 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 way brighter, and that might make the rings appear a little bit more clearly, but they're still pretty hard to show up. You can see them kind of here on the bottom, but Neptune does have very thin rings. And in the movie, he ends up flying through them in a spaceship, which is fairly accurate because even the rings of Saturn, which are much denser than Neptune's, they're on average only 60 feet thick, so you could actually almost walk through them. And the particles are fairly small. Well, they range in size. Some are very big, but a lot of them are very small. So you potentially could fly through them very slowly without too much damage. So let's check in here. We've got Sylvia saying hello from Independence. And Amy says, did we miss your birthday? Not my birthday. My birthday is in July. So you got plenty of time. You may have missed the bird day, though. The bird was out a little bit earlier in the stream, but she's chilling in her cage right now. All right. Patient says, did NASA did a pretest on the rockets? Why did they shut down early? How does this affect future rocket test? Let's see. So normally I do some news updates on my streams. I didn't have time to do that today, and actually I missed this little bit of news item. But to answer your question, so it looks like NASA did a test on its moon rocket, but there was an engine problem, and so they may not be able to do a test launch here before the end of this year. So there'll be a lot of working. That is the Space Launch System. It looks like there was a test, and that was an uncrewed craft, so nobody was hurt in that. All right, so let's talk about, if I can find my screen, there we go. Talk about Star Wars a little bit. I've actually touched on Star Wars a little bit before during my first Hollywood stream, or the other movie stream on May 20th of last year. So we're going to skip some of the things I talked about. I talked about if the Death Star could have exploded a planet. And I also talked about planets with two suns like Tatooine. But one thing I didn't talk about is explosions in space. So in space, or in Star Wars rather, there is a lot of space battles, and in those battles you hear a lot of explosions. You know, even the planet Alderaan exploding was very loud, and here is the video of that. A lot of Death Star-y things. There we go. So in the movie, Alderaan blows up, and you can hear the explosion very, very loudly. Now, it's often said that there is no sound in space. In fact, very famously, the Alien movie used the tagline, "In space, no one can hear you scream." And that is mostly true to a point. Now, conventional sound requires something to travel through, some sort of medium, and it's created when particles compress and expand. In space, space is a vacuum, so there are so few particles that any signals would die away quickly. Even massive explosions and contractions from events like solar flares and supernovas would not create a sound that we would hear with just our ears. But there is another type of event that doesn't require particles to propagate its waves at all, and that is black hole mergings. So, sound travels in waves, but like I said, waves don't necessarily need a medium to travel through. Certain types of waves don't, and that is gravitational waves. So gravitational waves happen when black holes collide, and they travel through and ripple through the very fabric of space itself. Now, in 2015, an observatory called the LIGO Observatory, which is actually an observatory in space, detected waves from the merging of a black hole, and they converted that to an audible sound. And so what I wanted us to do today is I wanted us to listen to some black holes merging. So check this out. We're gonna cut our background music out a little bit, and we're gonna bring in this audio. So I want us to listen to what black holes merging. Now, black holes are massive objects that suck in everything, and light can't escape them, and they eat entire stars. And when two black holes collide, I want you to hear the sound that two black holes colliding makes. Everybody ready for this? Here it is a little bit higher in pitch. Hopefully you guys can hear that. So yeah, so if you could hear that, hopefully you could. The sound might have surprised you because it was more just like a little blip. It went whoop, and that's what black holes merging sounds like. So again, that is the sound. So we've converted those waves to a frequency that humans can hear, but those waves are created by black holes merging, and they just propagate in different ways than traditional sound waves. So just kind of a funny thing I wanted to bring up. I wanted us to listen to the sound of black holes merging. It might have been a little bit different than you may have originally imagined. There's one more movie to touch on, but let's jump back into the comments. John is watching from Rochester, New York. Thanks for watching, John. Remember, if you have any comments or questions, be sure to put them. We have one movie left to discuss, so now's your chance. If you have anything to say, speak now or forever hold your peace. But the last movie I wanted to talk about a little bit is the movie Contact. And this is a great movie from 1997, and it's an adaptation of a novel that was written by Carl Sagan in 1985. And he actually was working on this originally as a screenplay for a movie, and they first released it as a novel, but then it became a movie. But in this, if you haven't seen this movie, I definitely recommend it. There's a lot of good science, but it is a great, just a philosophical movie, just that tackles a lot of ideas that are pretty broad. And it's a good personal story, very well acted. By Jodie Foster and all the rest of the cast. But there are a lot of interesting things to talk about. Obviously, since this was written by Carl Sagan, who was a very famous astrophysicist and science communicator, you would think that there's probably a lot of good science in it, and there definitely is. So I want to talk about, as a general premise, what happens in this movie is that Jodie Foster's character here works in the search for extraterrestrial life. Okay, and she is at an observatory and listening to signals from outer space, basically. And in the movie, they receive a signal from an intelligent life form. Now, there are people who are looking for intelligent life forms out there. There is the SETI Institute, which stands for the Search for Extraterrestrial Intelligence. That's a real nonprofit organization founded in 1984. And they use the Very Large Array, which is the array of telescopes that's actually featured in the film there. You can see it in the picture. And I believe I have another picture there. That's a real picture of the Very Large Array. Now, in 1974, we actually sent a signal to space. So we listen to signals all the time, but we've actually also sent signals to space. Now in the movie, the extraterrestrials received radio broadcasts from Earth and sent them back to us here on Earth. But we've been sending messages to space as well. So this is what's called the Arecibo message. And this was actually created by Carl Sagan, as well as another famous astrophysicist named Frank Drake, who created the Drake equation, which we'll talk about later. And we've talked about in previous streams, actually. But this message that was sent out in 1974 to a globular cluster called M13 has a lot of interesting components. Now, this globular cluster is 25,000 light years away, so it'll be a long time before they even receive this signal. Any planets there, and we don't even know if any of those planets have life, of course. This was mostly just sort of a demonstration or a test of this type of thing. But it's still an interesting signal to talk about. The contents of this, going from top to bottom, first of all, in white at the very top, are binary numbers, and this is to make it obvious that there's an intelligent life form talking here. And then next are the atomic numbers of the elements that make up DNA. And then next, that's in pink. Then in green, we have nucleotides of polymeric DNA. And then in white here, we have a binary representation of the number of the nucleotide base pairs in the human genome. And then around it is the approximate shape of a double helix DNA molecule. And then in red, of course, we have the shape of a human. On the left is the average height of a human in binary. And then on the right is the global population of the world in 1974 in binary as well. And they use binary because that is sort of the most basic form of numbers, and we find binary in nature as well. But most of the counting we do is in base 10 because we have 10 fingers. But there are a lot of computers use binary, but computers also use another numbering system called hexadecimal that uses 16 digits. So there are a lot of different measuring or number systems. So we wanted to use the most basic number system that hopefully aliens would recognize. Okay, then underneath that we have diagram of the solar system showing which planet we are in, so that if somebody tried to find us, they could find us. And then we have a picture of the Arecibo telescope. Now, this is the Arecibo message, which was broadcast from the Arecibo telescope in 1974. Arecibo, unfortunately, was in the news recently because last year it did, unfortunately, collapse. Now, this was very tragic because this telescope has been around for decades and has provided some very important science to us, such as searching for near-Earth objects that could be dangerous to life on Earth, as well as sending these signals into space. We talk about the Arecibo collapse in more detail during my December 28th live stream, which was our 2020 retrospective. So we talk about all the news that happened in the year. So unfortunately, this type of message has not been sent again recently, but in the movie Contact, they receive a message from space. And the message is they're listening to the star Vega. Now, Vega is a very close star to us. It's about 25 light years away. And that's why in the movie, the aliens first send a radio signal back to us from about 50 years prior, which kind of makes sense timeline-wise, as it would have taken the radio signals, which are just light waves, traveling 25 years to get there and then 25 years to get back. So again, I talked about the Very Large Array. This is a real telescope array. It's the most productive telescope, a radio telescope site in the world. It has 28 to 25 meter radio telescopes, and it is used by the Search for Extraterrestrial Intelligence, as well as many other science organizations. They use it to look for galaxies and quasars and pulsars and gamma ray bursts, black holes, all sorts of cool stuff. Now, in the movie, Ellie, the main character, likes to listen to white noise of the array in like her headset. And it provides for a great, Hollywood effect, of course. But real scientists wouldn't actually listen to the signal. They would have computers dissect that signal. And in the movie, they mentioned that the power of the signal was about 100 janskis, which is a real unit. It's a unit of radio energy. Most sources in the sky are measured in millijanskis, or 1,000th of a jansky. So 100 janskis is pretty big, and it's a big enough signal that she might have been able to hear it through her headset. So there might be some truth to that. Now, in the movie, there is intelligent life out there, and that is at the star Vega. So let's go back over to Space Engine, actually, and let's see. Let's go back to Earth first, and let's select Vega. So as we can see, Vega is about 25 light years away, and Vega is in the constellation Lyra, which is up right now. We actually talk about it in our live stream. And we can travel to Vega here in Space Engine. Now, Vega is going to be simulated here, and it is a white main sequence star. It actually rotates so quickly that we can see it has a very oval shape, kind of looks like a football, which is kind of cool, and that is real there. Now, in our simulation here, it doesn't look like Vega has any planets around it. Our simulation sometimes adds fake planets, but in this case it didn't add any fake planets to Vega. So we're not sure if there are any planets around Vega. Scientists have not found any planets around there specifically, but perhaps a planet or a civilization nearby there picked up the signal anyway. But the question and the last thing I wanted to talk about in my stream was, is there really intelligent life out there? How plausible is it that there is life out there? Now, there are a number of scientists who have attempted to figure that out. For example, Frank Drake in 1961 developed the Drake equation, which is a estimation that he came up with that was kind of a theoretical estimation of the approximate probability that there is intelligent life out there. And if you do the calculation here, which you can see on the screen, then there could be anywhere from 1,000 to 100 million civilizations in the Milky Way galaxy alone. And that seems very optimistic, and we haven't heard from any of those yet, of course, as far as we know. And again, this is a very theoretical equation that is based on just very broad theories. How much stock we want to put in this is kind of up to you to decide, honestly. But the question remains that we think that it's pretty likely that there must be life out there. After all, there are 500 billion stars in our galaxy. We think half of them probably have planets around them. And then our galaxy is one of countless others out in the universe. So why have we not heard from extraterrestrial life? And this is called the Fermi paradox, which is named after an Italian-American physicist named Enrico Fermi. He saw this Drake equation, and he pointed out that there's a contradiction, right? Because this predicts that there are a lot of civilizations, but why is there no evidence that there are other civilizations? And there are a number of theories that could explain this Fermi paradox. For example, there's some crazy theories, like maybe we're living in a simulation. Who knows? There is also, the theory that maybe they're already here and we just haven't recognized them. One thing about life is that we look for life similar to our own. All the movies with aliens, they look like little green men. They have 2 eyes and 2 arms and 2 legs. But in reality, life is probably going to be unrecognizable, life that exists out there in the universe. So if it is already here, we may not even notice it, or we may not even recognize it when it comes. Maybe we're looking for the wrong things. Maybe we're looking for radio waves, but we're looking in the wrong frequencies. Maybe they're in unlikely places. We look for alien life around planets that are in habitable zones, so zones close to their stars and kind of a similar Earth-star distance relationship, basically. But maybe our life is unique and most other life out in the universe is totally different, so maybe we're looking in the wrong place. There's a lot of other theories. Maybe they've already visited us. Human life and recorded human history is only a small fraction of the history of the Earth. We've only been recording history for about 10,000 years, give or take. A couple millennia, but the Earth has been around for billions of years. Who's to say aliens didn't come to the Earth back in the time of the dinosaurs, and they saw dinosaurs walking around, and they thought, there's no intelligent life here, and they checked it off a box, and they just left. Another idea is that intelligent life doesn't exist for very long. Maybe spacefaring civilizations only last for a few hundred or thousand years, and maybe they took place, 5 million years ago, and they've already been extinguished out of existence, and they didn't last long enough to find us. So there are a lot of theories that could plausibly explain why we haven't experienced alien life out there. I would say don't give up hope. There's likely alien life out there, and whether or not we will experience it in our lifetime, that's probably a little less likely, unfortunately. But that doesn't mean we shouldn't explore space, of course, which we will continue to do. All right, so that does bring us, wow, 45 minutes. We're actually a bit under schedule. That's awesome. That does bring us just about to the end. If you have any last second questions or comments, be sure to put those in the comment section. A couple other tiny little cleanup things I wanted to talk about for Contact. At the very beginning of the movie, she is looking at a meteor shower through a telescope, which is a little silly because you wouldn't use a telescope to see a meteor shower. You can see those with the naked eye. And the next meteor shower is the Lyrid meteor shower, which is going to be taking place in April, and it will peak typically around late April. This year it should be around April 16th to April 26th. So that meteor shower should be visible with the naked eye. So be sure to mark your calendars for that. Also, at the end of the movie, without spoiling too much, there is a bit of maybe sort of time travel involved. And if you want to learn more about time travel, our TV astronomy stream back in September 28th, I talk about Doctor Who and the science behind that. So if you want to learn about if time travel is possible, then be sure to check that out. Oh, one last other thing I wanted to mention. Now, of course, one last little plug. Don't forget that we do live star tours at the planetarium, and we've done them on our streams. We do them occasionally on our streams as well, but you can come to the planetarium to see a seasonal star tour. But I'm going to use a stellarium here to talk about one last thing with Contact, and that is Vega, so the star that they were receiving the signal from. At one point in the movie, there was some drama because they were worried about getting the signal done in time before Vega set. And so Vega does set in the early evening here in Kansas City. There's Vega. It's actually setting pretty soon in about half an hour. But there didn't need to be that much drama in the movie because they could have called up their friends up at the Onsala Space Observatory in Kungsbacka, Sweden. Let's see. Kungsbacka. Okay, keep pressing the wrong button. There we go. They could have called up their friends down in Sweden because Vega is visible up in Sweden, and Sweden is far enough north that Vega is circumpolar. So that means Vega will stay up all night long. It'll never set. So circumpolar stars are something we sometimes talk about in our star tour. So if you're curious about the night sky and how some stars can rise and set in certain places, and in other places they don't rise and set, then be sure to check out one of our live star tours at the planetarium. But we are going to wrap up by checking into the comment section and seeing what everybody is saying. Stephanie says, black holes colliding sounds adorable. Wasn't it kind of cute? It just went bloop. It just is kind of funny. You'd imagine them being a little more violent and explodey. Marie gives the cool sunglasses emoji and says, learning so much. Awesome, Marie. I'm glad you're enjoying this. And I'm glad you think science is cool. Linda says, love Contact. Contact is a great movie. I need to see it again sometime soon. It's been a little while. Sylvia, I assume Contact is your favorite as well. Looks like Granny wants to know if comics were ahead of books relative to predicting the future of space travel. That's a good question, Granny. And a yes and no. So there were some great comics and authors. There were some authors that were writing books back in the 1800s about traveling to space that got some things right and some things definitely not right. And comic books came around, of course, a bit later, sort of in the early 20th century. But, off the top of my head, I'm not thinking of any specific things that comics may have gotten right before novels. After all, a lot of comic books were written by novelists back in the day and still are today. But that's a great question. Lisa says, wow. Marie says, Contact was good. Eric says, great movie, especially the end where she had to consider faith. Yeah, it does deal a little bit with faith and religion and philosophy and ethics and all sorts of cool things. I definitely recommend watching it. Linda says, Interstellar was a good space movie. Indeed it was, Linda. And if you want to learn more about the science of Interstellar, I did talk about that on my first Hollywood live stream back in July 20th of last year. Remember, you can watch all of our past live streams on our YouTube channel. Just go to YouTube and search for Arvin Gottlieb Planetarium. And by the way, if you're watching on Union Station's Facebook page, be sure to go over to the Arvin Gottlieb Planetarium's Facebook page. Give us a like and subscribe. And on YouTube, please like and subscribe us there. We're very close to 100 subscribers, which is a big milestone on YouTube. And that would also let us do some, it would make us legit on YouTube. We could actually be an official creator there. So please subscribe to us on the YouTube channel. Helps us a lot. Linda says, thank you, Patrick, and Science City Union Station. Thanks, Linda, and shout outs, of course, to Science City and to Union Station. Beautiful buildings and amazing attractions. Be sure to check them out at some point. Amy says, maybe we asked the wrong question. Oh, you're thinking maybe if we're trying to reach extraterrestrials, maybe we are asking the wrong questions. That's true. Well, maybe we already know the answer. Maybe the answer is 42. There's a deep cut for you there. Eric asks, besides the probability of life out there, don't you need to figure out in the time civilization is this? At many billions of years, it is possible advanced civilizations have existed, but they just died out. And the big factor is the chance two advanced civilizations exist at the same time. Right, exactly. I mentioned that a little bit, but that's exactly right. We don't really know how long spacefaring civilizations will last. We don't really know how long our civilization will last. We've lasted a couple thousand years, but we've only been looking at the stars or studying the stars through science for a couple hundred years. So maybe alien life is out there, but maybe they're a couple thousand years behind us. So who really knows? And having them line up perfectly seems pretty rare. Marie says, thank you, Patrick and Science City. Thanks for watching, Marie. Chris says, thank you again. Thanks for watching again, Chris. Marie says, Doctor Who is a favorite. Well, be sure to check out that live stream then. You definitely enjoy our TV live stream from September 28th. Jane says, thank you. Thank you for watching, Jane. And Rachel as well. Thanks for watching, Rachel. And I think that may have actually wrapped us up. Thank you so much, everybody, for tuning in to another one of our Planetarium live streams. This was live stream number 57. How crazy is that? I don't know about y'all, but it's been quite a year. And it's only the third week of 2021. But it's been quite a crazy few months. But I appreciate all of you continuing to tune in for these live streams. We're going to keep them rolling. Next week, we're going to do a live stream about satellites to celebrate the anniversary of the first American satellite sent to space. That was the Explorer 1 mission. So we're going to talk about some famous satellites in that mission. Should be a lot of fun next week. So tune in for that. It'll be Monday at 6 p.m. Same place, same time. We've got fun topics planned for the next few weeks and months as well. We're going to be talking about some ancient Western astronomy, talking a little bit about Greek mythology, which we actually not touched on that much. Talking about ancient British astronomy is in my plan. We're going to be hopefully doing a star tour for our early learners, so we'll be doing that and announcing that hopefully sometime soon, and that'll be specifically for our younger audience. We'll dial things down a little bit and start from the beginning, talking about astronomy from a very, very basic level, so some of our youngest audience members can enjoy that. So stay tuned for that. that should be coming soon. But a lot of other fun topics on their way. So thank you all so much for watching. And Cindy laughs at the 42 joke. That is the answer to life, the universe, and everything. But we don't know what the question is. Amy says, maybe we are too primitive. That's true. Tasha says, thanks, Patrick. Thanks for watching, Tasha. Stephanie says, thank you as well. And thank you, Stephanie. Thank you, everybody. I have been Patrick Hess, your planetarium specialist. Hope you have a wonderful week, and we will see you next week, next Monday at 6 o'clock. Bye, everybody.